if any of the parameters you are not grasp it, just write whatever the parameters you have grasped it while we are taking down the given data. You'll come to know. Okay. It's a simple problem. Okay. It is not so difficult. I think all the problems are not so difficult. They are repeated procedures. Okay. Same formula we'll be using, but you have to you have to take care about the units. So that is the area where you'll go wrong. Okay. Shall we take the given data now? Okay. So what all is being given? Can you narrate me? Given data. Now, what are the other parameters given now? Trial of single cylinder oil engine working on dual cycle. So it's a single cylinder, correct? It's a single cylinder, but it is working on which cycle? It is working on dual cycle. Next. Observations were made. Oil consumption. So oil consumption is nothing but it is mass flow rate of fuel. How much is the oil consumption? 10.2 kgs per hour is the oil consumption. Now, CV value of the fuel. So CV value of the fuel is how much? It is 43890 kilojoules per kg. So this is the value of CV. Next, air consumption he has given. Okay, so that is, I can say it is mass flow rate of air. See, mass flow rate of air would come in exhaust cycle. So we'll maintain all these parameters at a single step. So mass flow rate of air is given. How much is the value there? 3.8 kg per minute he has given. That's great. Now, engine parameters we will note down at another end. Okay. So speed is how much? Speed is 1900 RPM. Torque on the brake drum he has given. So brake drum parameters we will note it down at the other end like this. So directly he has given the torque. That's beautiful. So how much it is? 186 Newton meters. So this is the value of torque. Okay. Next, quantity of cooling water. So cooling water parameters he has given. Again, we will note it down at the other end like this. Somewhere cooling water. So mass of water used. MWF. Flow rate he has given since it is kg per minute. So flow rate it is 15.5 kg per minute. So this is a parameter. Temperature rise of the cooling water. So temperature rise of the cooling water. So how much is that? It is 36 degrees Celsius. Okay. Next, exhaust gas temperature. So exhaust gas temperature, I would take it as T2. That he has given as 410 degrees Celsius. Okay. Now this is exhaust gas temperature. That means the temperature of the gases which is coming from the silencer. So that is what he's talking about. Next, room temperature he has given. And room temperature, I would be taking it as T1, which is 20 degree Celsius. And CP of the exhaust gas he has given. How much is the value? It is 1.17 kilojoules per kg Kelvin. If you observe, all these parameters which I have listed at the corner, for example, all these parameters, all this one. Okay. are for the exhaust gas calculations. Okay, it is for the heat lost due to exhaust gas. So while drawing a heat balance sheet, this also would come heat lost due to the exhaust gases. In order to calculate that, all these parameters he has given: mass flow rate of air, exhaust gas temperature, room temperature, and CP, and so on. Okay. Now, anything else which is being given but I have not listed? Any other parameter given but I have not listed? Just check. What we need to find here? What we need to find? Calculate break thermal efficiency. So one thing he has asked is break thermal efficiency you must calculate. And other thing he has asked to draw a heat balance sheet. Can you tell me on which basis, hour basis or minute basis? On which basis should I draw the heat balance sheet?
Minute basis.
So you mentioned there you have to draw it on the minute basis. That's great. Shall we start the solution then? Solution. Okay. So first thing what it is asked? First thing it is asked is the break thermal efficiency. So how do you calculate the break thermal efficiency?
BP divided by m dot f into c.
BP divided by EMF dot into CV. So do I have the value of BP? Do I have the value of BP? So BP we will calculate now. So BP is equal to 2 pi NT by 60. I think torque and as well as the speed of the shaft is being given here. So take the values from those. 2 pi speed is 1900 which is given, and the torque is 186 divided by 60. So whatever you get the value, it would be in watts. And EMF dot is being given there. EMF dot is 10.2 kgs per hour. So we want in kgs per second. So 10.2 divided by 3600 kgs per second. Okay. Even the CV value is being given. CV value is how much? 43980 kilojoules per kg. Now calculate the value of BP. In turn, you can calculate the value of the break thermal efficiency. So that is equal to MFS 10.2 divided by, because be careful, you have to substitute in kgs per second because the numerator as well as the denominator should be of same units. If you are substituting BP in kilowatts, you have to substitute MF into CV also in kilowatts. I have already explained you how to do that. Okay, 10.2 divided by 3600 cross CV value was 43980. Now, give me the value of BP, in turn give me the value of efficiency in terms of percentage.
37 kilowatt BP, sir.
Okay, it's 37 kilowatts. Just check the answer. So just substitute 37 here in kilowatts. So give me the percentage. For the percentage, you have to multiply it by 100 there.
$29.69.
How much?
29.69.
29. Okay. 29.69. Now, all of you draw the heat balance sheet. Come on, everyone. I would just take it from the other end. You draw the heat balance sheet. Share. So how are you feeling the problems, guys? Whether they are easy or if you are feeling still difficulty about the problems?
Easy, sir.
Heat. The speciality of these problem is there will be no twists and turns in the question paper you can expect. So all the question would be lengthy, but remember, ಎಷ್ಟು question ಉದ್ದ ಇರುತ್ತೋ ಅಷ್ಟು ಡಾಟಾ ಸಿಗುತ್ತೆ ನಿಮಗೆ. Correct? So no need to worry about these problems. Just remember 4 to 5 formulas and it will be done. So heat balance sheet you have drawn, and this is for which basis?
Minute basis.
Exactly. Okay. Now, okay. Now you see, even in this particular problem, unaccounted heat, I have to take it on the other hand. Okay. So the special thing which is given in the problem is they have in the problem he has given to calculate heat lost due to exhaust gases, since the exhaust gases parameters are given. Okay, so that is a special thing in this problem. See, all these parameters are given, no? So that's why you have to calculate heat loss due to exhaust gases. All the other things remain same, I guess, right? All the other things remain same. Start to calculate now. QS calculate ಮಾಡ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ? What do you mean by QS? QS is heat supplied. How do you calculate it? MF dot into CV, calculate it, and give me the value in kilojoules per minute. And take care of the units. I always repeatedly say you have to always take care of the units. So in what unit should I substitute the value of MF and CV so that I would get the end result as kilojoules per minute? Yes. In what unit should I substitute the value of MF?
So divided by 60 we need to do now, sir, because minute
Exactly.
the 10.2
Exactly.
MF.
MF value given is what? It is 10.2 kgs per hour. But if you substitute here in kgs per hour and CV value in kilojoules per kg, what is the end result you are going to get? kg get cancels and it would arrive in kilojoules per hour. Is that the desired unit? Definitely not. we require in kgs per minute. So ಅದಕ್ಕೆ ಏನು ಮಾಡಬೇಕು? What should be done? What should be done?
Divided
Divide
by
by
60.
Divided by 60.
You have to substitute why you are
Divided by
dividing by
60.
60. Why you are dividing by 60?
Because
You have to
sir, we are
substitute.
minute.
Exactly. So we are substituting the value of MF in kilojoules per minute. So that's why MF is equals to 10.2 kgs per minute, and CV value would remain same. How much is the value of CV? 4398. Sorry, 890 la something like that. 890 kilojoule per kg. Now, if you substitute these two values, whatever the value you get, that would be in kilojoules per minute. So MF is 10.2 divided by 60 cross 43890. So whatever you get now, it would be in what? It would be in kilojoules per minute. Yes, took you, sir. How much is the value?
7.46 into 10 power 3.
Okay, 7.46 into 10 to the power of 3. So I would take that value of 7.46 into 10 to the power of 3. Okay. Now go for QBP. QBP, it is nothing but the value of BP, but what is the criteria? The unit should be in kilojoules per minute. But what value you have? BP is equals to how much? You have calculated, no? How much is the value of BP? Estido no?
37.
37 kilowatt.
37 kilowatts unto. Andre kilowatts andre ಏನು ಅರ್ಥ? What do you mean by kilowatts?
Joules.
kg per hour.
Kilojoules per second.
Kilojoules per second.
It is joules per second, but ನನಗೇನು ಬೇಕು? What should I require?
A minute.
37 into 60.
So what should I do? You have to do 37 into 60 so that you can convert it into kilojoules per minute. Now, what is the value of QBP in kilojoules per minute? 3, 6, 7, 42, 42.
2.22 into 10 power 3.
Okay, 2.2 into 10 to the power of 3. I would take that value and write here 2.2 into 10 to the power of 3. Okay. Now, next in calculate ಮಾಡಬೇಕು. What should be calculated? QCW. What is QCW? What is QCW? Hey, what is
Cooling
QCW?
water.
man?
Cooling water.
Cooling water. Okay, so for that formula is mass flow rate of cooling water cross Cp of cooling water cross temperature difference of cooling water. Whether all these parameters are given, mass flow rate of cooling water has been given. How much?
15.5.
So it is 15.5 watt.
Kg per minute.
Oh, kg per minute. I think already it has been given in minute basis, right? No need to worry then. Cp value of water. I told you to remember this. How much is that? That is 4.18 into 10 to the power of 3 kilojoules per kg Kelvin. So that is the value of the Cp of water. Okay. Now, next is delta T of water. Temperature rise of water is being given. I think it is 36 degree. 36 degrees. Okay. Now, just substitute all of that. All are in the favorable units for us. 15.5 into 4.18 into 10 to the power of 3 cross 36. Now, whatever the that would be automatically in kilojoules per minute. What is the value?
Two point three three into 10 to the power 6.
2.3 into 10 to the power of 5. I would take that 3. So
10 to the power 6, sir.
6. ಅಷ್ಟೊಂದು ಬರುತ್ತಾ? Then don't substitute here. Okay. This is 4.18. That's 4.18. Okay. ಈಗ ಹೇಳಿ. ಈ ಕರೆಕ್ಟ್ ಉಂಟಾ?
2.3 into 10 power 3.
Okay. Now same thing, you substitute in the table there. It is 2.3 something into 10 to the power of 3. And next one is heat loss due to exhaust gases. That is QEG. For that, the formula is mass flow rate of air, okay, cross CP of air, the exhaust gas, cross the temperature rise of air. So what are the parameters given there? Mass flow rate of air is being given. Mass of air is being given. Hey, ಹೇಳ್ರೋ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 3.8 kgs per minute. ಹೌದಾ? So 3.8 kgs per minute. So already minute basis ಇದೆ. Lucky fellows. So CP of EG. CP of exhaust gases. ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 1.17 kilojoules per kg Kelvin. So just take that 1.17 kilojoules per kg Kelvin. Delta T of air. Temperature difference. I think direct ಆಗಿ ಕೊಟ್ಟಿಲ್ಲ. T2 ಕೊಟ್ಟಿದ್ದಾರೆ, T1 ಕೊಟ್ಟಿದ್ದಾರೆ. ನೀವೇನ್ ಮಾಡಬೇಕು? T2 minus T1 ಮಾಡಬೇಕು. So T2 minus of T1. What is T2? It is 410 minus T1 is 20. So it is something around 390. Now substitute all the values here. So it is 3.8 cross CP value as 1.17 cross this one is 390. So what is the value? EG. So whatever you get the value, it would be automatically in kilojoules per minute. Okay, it is 1.73
kilo. Okay, 10 power 3.
Kilo already there. 10 to the power of 3.
3.
Okay, so I would take it as 1.73 into 10 to the power of 3. Now, Numan Ahmad. So how do I calculate the unaccounted heat? Numan Ahmad.
Sir, all the heat.
How do I calculate unaccounted heat? Yes, anyone? How do I calculate unaccounted heat?
QS minus QBP plus QCW plus QE.
Excellent. It is supply minus the consumption. Supply is to 7.46 supply ಮಾಡಿದ್ದೀರಾ, ಅದರಲ್ಲಿ 2.2 BP ಹೋಗಿದೆ, 2.3 cooling water ಹೋಗಿದೆ, 1.73 exhaust gas ಅಲ್ಲಿ ಹೋಗಿದೆ. How much is unaccounted? So this minus of all this, have to do it and give me the value.
1.23.
Very good. So Kev, should I write everything? Just write. It is QS minus all this. It is QBP plus QCWF plus QEG. How much is the value? Unaccounted?
1.23.
1.23 into 10 to the power
10
of
power
3
3.
kilojoules per minute. Now same thing, substitute here. It is 1.23 into 10 to the power of 3 kilojoules per minute. Now add all this in the sense, add all this. It should be equal to 7.46 into 10 to the power of 3. Add here total. Okay, that's great. Now what you have to do, you have to calculate the percentages. How will you do that? Percentage of heat loss due to BP. How do you calculate percentage?
BP divided by QS into 100.
Exactly, do it. So you have the values here, 2.2 divided by this. Now, all of you just do all the things, this divided by this, put a percentage here. Next, this divided by this, put a percentage here. Next, this divided by this, put a percentage here. So calculate all the percentage, then at a stretch I would ask him, okay? Give me the percentages now. Heat equivalent to BP.
29.4. 29.4.
29.4. Okay, next, heat loss due to cooling water. How many percent? 30.8. Okay. Heat loss due to exhaust gases. How much percentage?
23.1.
23.1. An unaccounted heat is how many percentage?
16.48.
16.48. Now, if you add all this, I'm damn sure that it could be again 100. When you do that, your problem would be completed. So, any doubts in these problems, guys? Any doubts? Understood, everyone?
Yes, sir.
Yes, sir.
Okay, now we'll move to another problem, which is this. Volumetric efficiency. Okay. Just take down the data from this. So this is the problem where you learn to calculate volumetric efficiency. So suppose the problem if he has asked volumetric efficiency, and this is where you will calculate it. Okay. Now, all of you just mark your attendance in the Google Sheet within next few within 11 o'clock. Meanwhile, once you are marked, just copy this particular problem.
ಸರ್ ಅಟೆಂಡೆನ್ಸ್ ಹಾಕೋದಾ? Okay.
ಹೇಳಿದ್ದೀನಲ್ಲ 11 o'clock ಒಳಗಡೆ ಹಾಕ್ಲಿಕ್ಕೆ. Shall we start this? So air to a cylinder, let me write down the given data. Okay. Now, airflow to a four-cylinder.
Sir, can you show a question?
Yes. Yes. So after this, the task for you is you have to take the question papers. I have shared in the Google Classroom, I guess, right? Correct? Yes. So have you checked?
ಸರ್
Yes.
ಸರ್ ಇಲ್ಲಿ ಪಿ ಅಂತ ತೋರಿಸಿದ್ರೆ ಅದು ಅಟೆಂಡೆನ್ಸ್ ಆಯ್ತಂತ ನಮಗೆ ತೋರಿಸಿದ್ರೆ?
ಹೌದು.
ಓಕೆ ಓಕೆ.
ಡೌಟ್ ಇತ್ತು ಅಂದ್ರೆ ಕ್ಲಾಸ್ ಆದ್ಮೇಲೆ ಒಂದ್ಸಲ ಶೀಟ್ ಶೇರ್ ಮಾಡ್ತೀನಿ, ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳಿ.
ಓಕೆ ಓಕೆ ಸರ್.
ಗೂಗಲ್ ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ನಿಮ್ಮ ಕ್ವಶನ್ ಪೇಪರ್ಸ್ ಅಪ್ಡೇಟ್ ಆಗಿದೆ ನನ್ನ ಪ್ರಕಾರ. ಆಗಿಲ್ಲ ಅಂತಂದ್ರೆ ಒಂದ್ಸಲ ಹೇಳಿ, ನಾನು ಅಪ್ಡೇಟ್ ಮಾಡಿಸ್ತೇನೆ. ಅದರಲ್ಲಿ what you have to do is you have to look for the problems in those question papers when concerned with the IC engines and try to solve those. Okay, and every student has to give me a problem from the previous year question paper in the next class, from next coming classes. Is that clear? So it should not be similar. So once one student gave me and other student have to give me the another question. So make sure you have your own questions with you. I would ask anyone in the next coming class. Not the solution, but just the question.
ಕ್ವೆಶ್ಚನ್ ಪೇಪರ್ ಅಪ್ಲೋಡ್ ಮಾಡಲಿಲ್ಲ ಸರ್.
ಅಪ್ಲೋಡ್ ಆಗ್ಲಿಲ್ವಾ? ಸರಿ, ಮಾಡ್ತಾರೆ. Shall we start? So the given data is it's a 4-stroke, 4-cylinder engine. I would just write it. I would just draw an engine diagram. Okay. and I would write it. It is a 4-stroke, 4-cylinder. So how many cylinders it has? 4 cylinders it has. The airflow to a 4-stroke, 4-cylinder engine is measured by means of a 5 centimeter orifice. Now, there would be air inside to this cylinder, isn't it? There would be an inlet. Now, just a minute. Okay. For this particular engine, there would be a, what I can say, inlet pipe, isn't it? Through which the air flows. The air just flows with the help of inlet cylinder. Now, in order to measure the air flow rate, there would be an orifice connected. So this particular thing is orifice meter. Okay. I think you have learned this in your fluid mechanics, am I right? About the venturi meters, about the orifice meters.
Not started. Not started.
How much it has been covered there?
Module 1 teaching. Module 1.
Okay, buoyancy is being done. Submerged surfaces is being done.
No.
Then?
The differential manometer problems.
Yeah, sir.
Okay,
Pressure
manometer
measurement.
problem. Manometer problems.
Yeah, sir.
Oh, those are very interesting, man. Learn that very happily. Okay.
So we
That's very
cannot,
interesting. Huh?
so we cannot understand what he explains in the class.
Sir, his teaching is so not to that. Not
Okay,
up to mark.
wait.